we are discussing assignment problem, and we have taken this example. We have 4 jobs and 4 machines. J1, J2, J3, J4 are the jobs, and M1, M2, M3, M4 are the machines. And this matrix gives you the time taken to complete different jobs in different machines. Like this 26 means if job 2 is processed in machine 1, it takes 26 units of time, or in other words, if job 2 is processed in machine M1, the cost is 26 rupees. Both represents the same thing. And like this example, if I take 15 means if job 4 is processed in machine 3, it takes 15 minutes of time, or in other words, the cost for completing the job in job 4 in machine 3 is 15 units. So now our objective is to assign the jobs in such a way so that the total processing time is minimum. And one thing is to be kept in mind, that if a particular machine takes up a particular job, then that machine cannot take up any other job. And the other way around, if a job is taken by some machine, then that job cannot be taken up by any other machine. So you have to distribute, you have to allocate the jobs in such a way, one machine will be allocated to one job only. And similarly, one machine, one job, and other way around, one job, one machine. Now let's try to solve the problem. It is similar, assignment problem is also a linear programming problem, and it can be explained as a transportation problem. Here jobs are there, and jobs are available, and machines are required. So here you can say that 1, 1, 1, 1 and 1, 1, 1, 1, 4 jobs. So each job has 1 as a correspondence and 1 machines for each machine. So there are 4 jobs and 4 machines, and 4 jobs and 4 machines. So this is a balance problem. If you add 1 plus 1 plus 1 plus 1, so there are 4 rows and 4 columns. So as similar to that of transportation problem, here a problem will be balanced if the number of jobs is equal to the number of machine. In other words, if it's a square matrix, or you can say that the number of jobs is same as the number of machines. So if you have 4 jobs, if you are having 4 machines, then the problem is balanced. Otherwise it is unbalanced. So if it's an unbalanced problem, you have to balance. If the number of job is less, then you have to add our fictitious job, and with the cost. If you take an example like this, say instead of this, if you are having this 3 jobs and 4 machines, so it's an unbalanced problem. As I said, the first step is to check the problem is balanced or not. Then 3 jobs, 4 machines, so we have to add a fictitious job with processing cost as 0 units, and thus it will become a balanced problem. So it will become 4 rows and 4 columns. So it has become a balanced problem, and we can proceed to the next step. Or otherwise, if we are having so initially it was 11, 26, 15, 24. So we are 15, 10. So we are going back to that particular problem, and so it was the original problem was like that. And if the number of jobs, if the number of machine is less, then also it could be a unbalanced problem. So first thing is to make the problem as balanced. So we have to add a fictitious machine in that case as M4 and cost as 0 units. So that's how. First step is to check whether the problem is balanced or not. So if it is not balanced, you have to balance it. So either by adding rows or adding columns, so that the number of rows is equal to number of columns. So after you have checked whether the problem is balanced or not, then we go to the step 2. In step 2, what we do? For each row, subtract the minimum element of that row and write into a new matrix. So we'll do the row operation by finding out what are the minimum elements. So first row minimum element is 11, second row minimum element is 13, third row minimum element is 15, and fourth row minimum element is 10. So we have to subtract and write into a new matrix. So subtracting, what we get is, let's write that. So if you subtract 11 from 18, this becomes 7, then 15, then 6, 0. Second row you are subtracting 13, so this becomes 0, 15, 1 and 13. Then if you are subtracting 15 from 38, it is 23, then 4, then 3, 0, and finally last row minimum element is 10, so you are subtracting from that, subtracting 10 from each of them, so it becomes 9, 16, 14 and 0. So as I have said, for each row you have to subtract the minimum element of that row and write into the new matrix. So after we have done the row operation is the second step. Then we will go to the third step. So from the new matrix, what we will do, we will do the column operation from the new matrix. So what is the column operation? In column operation, for each column we will subtract the minimum element of that column and write into a new matrix. So I don't require this particular matrix right now, so I'll just rub it off. So I'll do the column operation on this particular matrix. So first column minimum element is 0, second column minimum element is 4, third column minimum element is 1, and fourth column minimum element is 0. So we'll do the same, similarly what we have done for the row, so we'll be doing the same for the columns. So first column, so before doing the operation, let's draw the matrix, and then we'll write. So if you're subtracting 0, it will remain unchanged, 7, 0, 23, 9. Then if you're subtracting 4, because in the second column minimum value is 4, so we are subtracting the minimum value 4 from the second column, so it becomes 11, 11, 0, 12. Third column minimum value is 1, so if you're subtracting, that is 5, 0, 2, 13, and last column the minimum value is 0, so it will remain unchanged, 0, 13, 0, 0, 0, 13, 0, 0. So after the row operation and column operation, we get this. So we have done the row operation, we have done the column operation. So first step was to check the problem was balanced or not. Second step was to do the row operation and write into the new matrix. And after you have done the row operation, then we will do the column operation and we write into the new matrix. So we have done gone to till step 3. So this algorithm we are discussing is called the Hungarian method. We have said that earlier, HUNGARIAN, Hungarian algorithm we are discussing. So Hungarian algorithm. Now we will try to, step 4 is the allocation. So step 4 is the allocation. What I have said, so looking at the rows first. So we'll look at the rows at the beginning. So looking at the rows first, find that row having single 0, assign at that place and block the corresponding column. So looking at the rows first, so we will look at the rows first at the beginning, and with that we will do that for the new matrix. So nothing to do with this matrix, so I am just rubbing this off. So with the new matrix, we will look at the rows first. So first row, yes, there is a single 0. So if you have find the single 0, you will assign at that place and block the corresponding column. So blocking the corresponding column, why you are blocking the corresponding column? As I have said, in a particular row and column there will be a single solution. So if a job is taken up, that machine is also blocked. So job blocked as well as machine is blocked. Then, so first row we have checked, second row 2 zeros will not do anything. Third row Third row there is single 0 because this 0 is already blocked, so this 0 has nothing to do. So third row single 0 is there, so I'll assign at that place and block the corresponding column. So I have blocked the corresponding column. Fourth row no zeros because this 0 is already blocked. So after you have done, and if you go back again, first row single 0 is there, so we have already assigned that. Second row 2 zeros, so we will not do anything. Third row single 0. So this row assignment is done. Row assignment is done. So after we have done the row assignment, means looking at the rows first. So we have already looked at the rows and assigned whatever possible assignments is done. And now I can't do anything because we are finding the rows with more than 1 0. So if we find rows with more than 1 0, we can't do anything. We will do something else. So next step is to the column assignment. We will be assigning with respect to the columns. So we will do the similar things as we have done for the rows. Now we will look at the columns. So looking at the columns, we will find that column with single 0, assign at that place and block the corresponding row. So whatever you have done for the row, we will do similar things for the columns. So when I am looking at the row, I will block the column, and when I am looking at the column, we will block the row. So first column, when I am looking at the first column, yes, there is a single 0. So if I can find the single 0, I will assign at that place and block the corresponding row. Block the corresponding. So then second column is already blocked. Third column, there was a 0, but this 0 is already blocked, as you can see. So we can nothing we can do. And fourth column is already blocked. So that means here my assignment process is done. So I have blocked all the zeros by drawing the number of. I can block all the zeros by drawing minimum number of lines, straight lines. Actually, the algorithm says you have to block all the zeros by drawing minimum number of straight lines. This can also be done in another way, but I think the way I am explaining is more useful. You can also do the same by first choose that line or choose that column or row which is having most number of zeros. As you can see here, the last column has 3 zeros, so we have blocked that. But where to assign, that is the difficult part. You can block that, but where the assignment is done, that becomes a difficult part. There is another process of doing the blocking part. Actually, the method says you have to block all the zeros by drawing minimum number of straight lines. But that is quite a difficult task to do. If there are lots of zeros, then how will you draw the lines? That becomes a little difficult to draw. Whatever I have said, that's a simple way of doing it. You could have done this way also. Like here there are 3 zeros, so you have blocked last column first. Then this particular row has 2 zeros, so you have blocked this row, and then this single 0 is left. Either you can draw this way or that way. It will not matter. But doing that process will not not help you to finding out the assignment. But the way I have said, it helps you to find out the assignment. And so after you have blocked all the zeros, the assignment part is over. That means we have got 3 assignments. But for optimum assignment, we need to have the number of assignment is optimum if the number of assignment is equals to the number of rows or number of columns. So in this case, there are 4 rows and 4 columns. So the number of optimum solution has to be 4. But we have got only 3 solutions. So 1, 2 and 3 assignments. So we have got only 3 assignments instead of 4. In this particular problem, we require 4 assignments, and those 4 assignments will be optimum. But we are required to have 4 assignments, but we have got 3 assignments. That means this solution is not optimum. To obtain the optimum solution, we have to do something important. Now please listen very carefully. This is not discussed in the class here. As I have said, the number of optimum solution is equal to the number of rows or number of columns. So in this case, there are 4 rows and 4 columns. So For number of optimum solution, we got 4 solutions, but we have got 3. So that means this solution is not optimum, so we have to improve. To improve, we have to find out the minimum element from the elements which are not blocked. We have to find out the minimum element from the elements which are not blocked. So what are the elements which are not blocked? This 7, this 5, this 23, this 2, this 9 and 13. So we have to find out the minimum element from the elements which are not blocked. So that is 2. And then you have to do 3 things. Very important. What are those 3 things? Number 1, subtract that minimum element from those which are not blocked. So you have to subtract that minimum element from the elements which are not blocked, number 1. Number 2, leave the elements as they are, which are blocked ones. So the elements which are blocked ones, you have to leave the elements as they are. So like this element 0, this element 0, and number 3, add that minimum element to those elements which are blocked twice. Which are blocked twice. So again I'll just try to explain. So if you look at this board, there are 3 types of elements. Either the element is not blocked, or another type is whether the elements are blocked once. Once means either by row or by column. And there are certain elements like this 11 over here. This 11 is blocked twice, both by row and column. So in this board, there are 3, in this box, in this matrix, there are 3 types of elements. Either they are not blocked, or they are blocked once, or they are blocked twice. So what you have to do, you have to find out the minimum element from the elements which are not blocked. Like, so what is the minimum element from the element which are not blocked? That is 2. And then you have to do these 3 things. So subtract the minimum element from those elements which are not blocked. Number 2 is leave the elements as they are, which are blocked once. And number 3, add that minimum element to those elements which are blocked twice. So whatever we have said, let's do that. So I'm just running this part what I have written and do accordingly what I have said. So let's draw the board, draw the matrix and do accordingly what we have said. So 7 is not blocked, so that means you have to subtract this minimum element 2. So this gives you 5. 11 is blocked once, so 11 remains unchanged. 5 is not blocked, so 2 will be subtracted, so this becomes 3. 0 is blocked once, so it remains as 0. This 0 is blocked once, so this will remain as 0. This 11 is blocked twice by row as well as column. So that means 2 will be added to that. So this becomes 13. This is blocked once, so it will remain unchanged. This 13 is blocked twice by row and column, so 2 is added. So that means it becomes 15. Then 23 becomes 21 because it is not blocked. 0 remains unchanged because it is blocked once. 2 becomes 0 because it is not blocked, so we are subtracting 2 from 2, it gives you 0. And this becomes 0 because it is blocked once. 9 becomes 7. 12 becomes 12 because it is blocked once. 13 becomes 11 and 0 becomes 0. So after we've got this new matrix, again we will do the assignment. As we have said, we will be looking, first we will look at the rows and then we will look at the columns. So we will look at the rows first and try to find out single zero. So first row, yes, there is a single zero, so we will assign and block the corresponding column. Second row, now there are two zeros, so we will not do anything. Third row, there are two zeros, so we will not do anything. Fourth row, there is no zero because zero is blocked. So we can't do. Again, if you go back, so two zeros, so nothing has changed. Now we look at the columns. So after we have done doing on rows, then we will do the columns. So first column, single zero, yes. First column, single zero, so we have assigned and blocked the rows. Second column, there are two zeros. Sorry. Second column, single zero, yes, single zero. So we have assigned and blocked the corresponding row. So nothing has changed. And by this we have done. See, we have blocked all the zeros, but still we are having three. We are having three assignments. 1, 2, 3, and we have blocked all the zeros. So that means still we have not got any optimum solution. So we have to do this again. So as we have said, by checking rows and columns, we have got only three solutions. So we have to do it again. So here also we have got three solutions. So no improvement is done. So we have to repeat the previous step again. That means again we have to find out the minimum element from the elements which are not blocked. Then we have to do those three things, like to subtract the minimum element from the elements which are not blocked. The elements which are blocked once will remain as it is, and the elements which are blocked twice will be there. That minimum element will be added. So if you check, you can find these are the elements which are not blocked. So, and the minimum element is 3. So we have to do the operations again. So let me rub the table at the top, and so we repeat the step. So minimum element, we have to find out the minimum elements from the elements which are not blocked, so that is 3, and do the operations as suggested. So if you have 5, we are subtracting 3 from 5, so this gives you 2, then it is 8, 0, and this will remain as 0 because it is blocked once, so it will remain as 0. This will remain as 0 because it is blocked once. 13 will remain as 13, 0 will remain as 0, and this 15 will be added, 3 will be added to 15 because it is blocked twice by row and column. So it becomes 18. Then 21 will remain as 21, 0, 0. Now this 0 will become 3 because it is blocked twice, rows and column. So 3 will be added to that, so this becomes 3, and this 7 becomes 4, 12 becomes 9 because 7, 12 and 11 are not blocked, so we have to subtract 3 from those. So it becomes 8, and finally this becomes 0. Finally this becomes 0. So by the operations we have got the new matrix. So we have got the new matrix. So 2, 8, 0, 0, 0, 13, 0, 18, 21, 0, 0, 3, 4, 9, 8, 0. And again we will do the assignment. So now first row has 2 zeros, so we will not do anything. Second row also has 2 zeros. Third row has 2 zeros, so we will just skip and go to the fourth row. Now fourth row has single zero. So fourth row has single zero, so I will assign here and block the corresponding column. So I have blocked the corresponding column. If I block the corresponding column C, now first row has become single zero because this zero is not participating anymore. So this first row has single zero. So I will assign over here and block the corresponding column. Now if I can do it by looking at the row or looking at the column. So if I look at the column also, I will get a single zero here. or if I look at the row also, I can get a single zero here. So if I'm looking at the column, I'll block this way, and again if I'm looking at this second column, I'll get a single zero here, so I'll block the column. So I have blocked all the zeros by my method, that the way I have explained, and now I have 4 assignments, 1, 2, 3 and 4. So as I have said, the number of assignments is equal to the number of rows and columns. So this assignment will be the optimum assignment. Hence, finally we will write down the assignments as, so write down the so we will get the assignments final, since we have got already 4 assignments. So we'll write down the final assignments as job 1 is assigned to M2. So if you remember, I have written as this is J1, J2, J3 and J4. And this was M1, M2, M3 and M4. So from here we can get J1 is assigned to M2, J2 is assigned to M3, J3 is assigned to M1, and J4 is assigned to M4. So J4 is assigned to M4. So these are my assignments, and total cost or total time can be found out from the original table that was there. So from the original table, whatever values were there in this particular position, M1, J3. So M1, J3 was 17. Then M2, J1 was 13. Then M3, J2 was 19, and M4, J4 was 10. So these were my 4 assignments that we have got, and so we add to find out the total cost or total time required. So that gives you I think 59. 9 plus 3 is 12, 12 plus 7 is 19, and yes, 1, 2, 3, 4, 5, so 59. So total cost is 59 units, and these are the assignments. So that completes the assignment part. So that is the final result. How you write the final result, that you have to write down the assignment as well as the cost. So that gives you the final result. So this is the problem that I have given to you for solving, and this is a cost matrix with 5 jobs and 5 machines. J1, J2, J3, J4, J5 are my jobs, and M1, M2, M3, M4, M5 are my machines. And this is the cost matrix, and you have to find out the minimum assignment. So which job is to be assigned to which machines. So as there are 5 rows and 5 columns, the problem is balanced. So we can proceed to do the row operation and column operation. So for row operation, let's do the row operation. So first row minimum element is 1. In fact, we can see for all the rows the minimum element is 1. So we will subtract it. This will become 3, 1, 6, 2, 0, 1, 8, 1, 6, 0, 5, 7, 6, 5, 0, then 3, 5, 4, 2, 0, and finally it's 4, 2, 8, 4, 0. So we have done the row operation. Then we will do the column operation. So I'm rubbing this off and writing this. So column operations. So first column minimum element is 1. Second column minimum element is also 1. So first column we will do. Let me draw it. So we are doing the column operation. After doing the row operation, we will be doing the column operation. So first column minimum element is 1. So this becomes 2, 0, 4, 2, 3. Second column also the minimum element is 1. So this becomes 0, 7, 0, 7, 6, 4, 1. Third column also minimum element is 1. So this becomes 5, 0, 5, 3, 7. Fourth column the minimum element is 2. So this becomes 0, 4, 3, 0 and 2. And obviously last column all of them are 0, so it will remain as unchanged. So we have already done the row operation and column operation. Now we will try to find out the assignment. So looking at the rows first, we will try to find out that row having single 0. So first row 3 zeros, second row 3 zeros, third row there is a single 0. So we will assign at the third row here and block the corresponding column. Now in fourth row we also got a single 0. So fourth row single 0 and block the column. Fifth row there is no 0, so zeros are blocked. So yes, if you check, if you look at the first row now, again if you look at the first row, then there is also a single 0. So because these two zeros are blocked, so I am assigning here and blocking the corresponding column. As I have said, while looking at the row, we have to block the column if I find an assignment, and while looking at the column, we have to assign the we have to block the row. So I think we have looked at the rows. Now we will look at the columns. So first column I can find single 0, so I have assigned. So I have assigned and block the second row. So how many assignments we have got? 1, 2, 3 and 4. So that means the solution is not optimum, because in this case there are 5 rows and 5 columns. So number of optimum assignment is 5, but we have got 4. So we have to improve the solution. So I leave it here for you. So how you can complete the solution, so that I have already discussed how to complete it, how to go forward from here. So I hope you can complete it, and we will discuss the rest in the next class.